Let's take a look at reflections, example 1. So in this example, we are given the verbal description, given triangle ABC with A at -1, 1, B at 2, 4, and C at 4, 1. We're asked to reflect triangle ABC across the y-axis. So in this case, when it reflects across the y-axis, our algebraic rule would be for all of our points x and y, we are going to make them become -x, y. So I'm going to carry that over to my table so I can fill in some points and then put them on my graph. So -x, y was my algebraic rule. The points given, let me grab another color, are A is -1, 1, B is 2, 4, and C is 4, 1. And then I'm just going to focus on this part that's for the table portion. So using my rule for reflecting across the y-axis, I need to change the sign of the x and keep the y the same. And we'll take a look on our graph in a minute as to why that makes good sense. Alright, so for A prime, that's going to give us +1, 1. For B prime, that will give us -2, 4. And for C prime, we'll have -4, 1 for our coordinates. So let's take a look at the graph. So we need to go to -1, 1 to graph A. B is located at 2, 4. C is located at 4, 1. And then we can draw our triangle ABC. Let me grab my green pen. So A prime is located at 1, 1. B prime is located at -2, 4. And then C prime is located at -4, 1. So notice, using our algebraic rule and then graphing, we should be able to tell that if you flip triangle ABC, the blue one, over the y-axis, the only thing that changes is your x values go from positive to a negative of whatever they were. So that's the only change that takes place. The y values stay the same. In other words, like the height of your triangle didn't change. It didn't go up or down by just flipping it over the y-axis. So like we've been looking at with this unit, our verbal description helped us to write out our algebraic rule, which we then used for our table, and then we put it on a graph, and we're able to connect all of these parts and pieces together. Alright, so that's it for example 1.